Hello again. I'm going to need one more video because for some reason my last one just suddenly stopped. Okay, so I got to the point where we worked out the coordinates of C and D. Now all we need to do, because those are the points where it crosses the coordinate axes, the area is just going to be 1/2 times 5/2 times 5/4. So 25/8 square units. And the mark there, you get 1 for working that out. I don't know whether I put that in the last video. 1 for there as well, and 1 for the final area. Okay, question 14. We definitely looked at this one in detail because it wasn't very well answered when I gave it to you in the PPE. So, we've got a function and it's got sine in it. So there's been some transformation here. It's been moved up 3 units. It's been multiplied by this -4 as well. So it's turned it upside down and stretched it as well. So there's quite a few different things happened to it. But regardless, you know that sine x lies between -1 and 1. So what I'm going to do is substitute that into h of x and see what happens. So I'm going to put in the 1 and I'm also going to put in the -1 as values of that sine x. This one gives me -1, this one gives me 7. So that tells me that the minimum value of that is going to be -1, the maximum is going to be 7. Now I want the maximum value of h and the value of x where it occurs. So the max value of h is 7. And this occurs when sine x equals -1 because it's been flipped upside down. So at that point, I'm just going to solve it for x and I get -90 degrees. So the points awarded here, you get 1 for that, however you've done it. 1 for knowing that it was -1 that gave you the maximum, not 1. And 1 for figuring out that value of x. You'll have to excuse me a little bit. I've got a bit of a sore throat and I keep clearing my throat and sniffing a little bit, so I am sorry. I can't imagine it's pleasant to hear on the video. Now this one, not a very nice thing to factorise. So what I did initially was just change it. I let x be sine theta and cos theta was going to be my y. So it just looked a little bit easier if I had it written like that. You don't have to, but if you do it this way, it's going to have an x and an x there, and an x there. And then somehow I have to make 5y squared. So here and here I'm going to have a 5y and a y. And I've got to make a 5 from 2 numbers that also add to give a 4. So I'm going to have -1 here and +5 here. And then to turn it back into what we want, I'm just going to replace that with the sine and the cos instead. Okay, so now we've got that far. We've got to take each of these and solve them. Now, I've said before, if you have something involving sine and cos, it's going to end up being tan. So sine theta minus cos theta equals 0, so sine theta equals cos theta. I'm going to divide both sides by cos theta, and you get tan theta equals 1. Over here, you get sine theta equals -5 cos theta. So that's going to give me sine theta equals -5 cos theta. So divide both sides by cos theta and you end up with, oops, sorry, I didn't mean that. Tan theta equals minus 5. Okay, now I have to solve them both. Solving tan is a little bit easier. So if I inverse tan this, I get 45 degrees. If I inverse tan this, I get negative 78.7. And I could draw a diagram, but actually all you have to do for tan is add on 180 because they repeat every 180. Same for this one. I'm going to add on 180 and I get theta could be 101.31. But also if I look back at the original question, I'm looking at theta up to 360, so I can go a little bit further here. So I'm going to add 180 again, and I get theta equals 281.3. And I'm just going to circle all of those and we'll have a look at the marks awarded. Okay. And I don't think I need that negative one. Okay, because the lowest I can go is 0. So I'm just going to put next to that one, not applicable. Okay, so the marks. So we get 1 mark for the simplification, the factorising up there. We get 1 mark for working out, done it again, 45 degrees. 1 mark for 225 degrees. A method mark for adding on the 180 here. And we also get an accuracy mark for all 4 of the answers at the end. So 1, 2, 3, 4. Final question, hurrah. But also probably one of the most confusing. It's a 10 marker, doesn't split it up a lot. So yeah, not the easiest to understand and break up. So what they've very kindly done for us, they've given us the gradient function. They've not even given us the equation of the curve. And they've not even given us this point here. They've given us a stationary point. So they've been really mean here. But if you know what you need to work out the area, we can get there. So we're trying to find the area of this region down here. And we all know that's going to end up being negative because it's below the axis. Now to work out the area, I'm going to need that point there. I'm also going to need the equation of the curve. So I need the equation of the curve. And I'm going to label that point A, I think. And I'm just going to put point A. So that's what I need. Now we need to look at the question and figure out how I'm going to find it. Well, they've given me the gradient function. So to get the original curve from that, I'm going to integrate. And it's not actually in the best format at the moment, so I'm going to rewrite it as that. So 2 minus 2x to the minus a half. I'm going to integrate that. 2 minus 2x to the minus half. And that gives me 2x minus 4x to the half plus c. That's the equation of the curve. Unfortunately, I need to figure out c. Well, they've given me some information to help me find c. They've given me a point on the curve. So that curve goes via, so the curve goes through 1 minus 2. So f of 1, if I plug 1 into this, that should give me minus 2 out. Okay, so 2 minus 4 plus c equals minus 2. Right, well, for that to work, c must be 0. So the equation of our curve is y equals 2x minus 4 root x. Brilliant. And let me show you what marks are available there before I end up deleting it all. So you get 1 mark for knowing to integrate it, 1 mark for integrating it properly, 1 mark for actually doing it and getting it correct, 1 mark for trying to work out what your C value is, and 1 mark for if you've done it right. So already we've got 5 marks there, just for getting to the point where we've got the equation. We've not even worked out the area yet. So I'm just going to delete all that so I've got some space. So we've worked out the equation of the curve, but still we've got a problem in that we haven't got the limits to integrate between. But what we do know, the curve crosses the x-axis. So the curve crosses the x-axis at A, and at that point y equals 0. So we've just worked out the equation of the curve, and a little bit of rearranging from here. I'm not going to do all the steps, but I end up with x equals 4, x equals 0. Well, clearly x equals 0 is going to be the starting limit. So at point A we've got 4. Brilliant. So marks available here. There's an accuracy mark there for working out that point. Now we actually have to do the integration. So I'm going to integrate between 4 and 0, 2x minus 4x to the half. Square brackets. And that's all between 4 and 0. If I plug in the 4, this is what I get. Take away, if I put 0 and I just get 0. That all comes out to be negative 6/3. Obviously it can't be negative. It's negative because it's below the axis. So our answer is 16/3 square units. And those final 4 marks, we get a method mark for knowing to integrate between 4 and 0. We get another mark for trying to work out the limits here and putting them all in, and 1 for doing it right. And we get the final mark down here for 16/3. That is the end of the video. I hope it's helped a little bit more than just maybe having the mark scheme in front of you. If not, let me know and I won't do it again, because it's taken me hours and I've bored myself, to be honest. So I'm sorry if I bored you to tears, but at least you're getting to hear my voice. Isn't that wonderful? Okay, I will talk to you soon. Take care. Keep safe.